Welcome back. This is another practice question on redox titration. So we want to consider another practice question. A contains 0.395 gram of KMnO4 dissolved in 250 cm cube of solution. Take note of this. We are given 0.395 gram in 250. You have gram here and it dissolved in 250. It means that you are not going to make use of this gram directly. You are not going to make use of this mass. This mass is supposed to be mass concentration, and any mass concentration must be in 1000, not in 250. So the first thing we are going to do is to ensure that we convert this one from that 250 to 1000. When the time comes, we are going to do that. B is a solution of 0.0362 mole per dm cube of iron 2 sulfate. Put A into the bread and pipette 25 cm cube of B into a conical flask. Add 10.0 cm cube of dilute H2SO4 and titrate with A. So these are the instructions. Repeat the titration to obtain concordance value. I have made videos on how to create a table without committing any error. So quickly now, let's calculate the question. We have already been given the ionic equation of the redox titration, right? Calculate the concentration of A in mole per dm cube. Remember that our A is what? Is KMnO4, and our B is FeSO4. So if the question is asking us to calculate concentration of A, which means that if you check the question very well, are we given concentration of A? All right. So we can say our A, which is a Ca, concentration of A, is equal to gram in 1000 centimeter cube divided by molar mass. So our mass conc of A, we were given 0.395 gram, which dissolves in what? In 250 cm cube. We were given 0.395 gram, which dissolves in 250. And you know that for us to make use of this mass, it must be in 1000 centimeter cube. So just put 1000 centimeter cube here and let us calculate how many mass, or what is the mass that will dissolve in 1000. What we are simply doing now is that we are converting this mass from 250 cm cube to that of 1000 centimeter cube, which is the same thing as a mass concentration. So X is equal to, if you cross multiply, which means 0.395 multiplied by 1000 divided by 250 is going to give us what? Class, talk to me. It's going to give us what? Our mass concentration now is now 1.58. Remember, it is now gram per dm cube, or gram per 1000 centimeter cube. This is not our destination. This is not where we are going. But we firstly solve the first aspect of it, which is our mass concentration divided by the molar mass. Let's quickly solve the molar mass separate here. Then we substitute into the formula. The molar mass of KMnO4. This is KMnO4. So let's calculate the molar mass of KMnO4. Our potassium is what? Is 39. Plus our manganese. Our manganese is 55. Plus our oxygen is 16. Multiplied by 4. Addition of everything. Talk to me, class. Use your calculator. Our molar mass here, it will be equal to 158. That's our molar mass. So let's substitute this value into the formula to get our what? Our molar concentration of A. 1.58 divided by 158. Our final answer here is 0.01. My student, if this is the final answer you got, please don't leave your answer like this, because this must be in 3 decimal places. Or let me say, it must be 3 significant figures. So right now, this is the final answer I got. I need to add more value, which is 0, 0, to make it 3 significant figure. And don't forget, the unit of molarity is what? Mole per dm cube. Don't forget to put correct unit. So we have calculated our concentration of A in mole per dm cube. The next one is to calculate what? Number of moles of MnO4. Roman figure 2 now. Roman figure 2. We have to calculate number of moles of MnO4 in the average titer. Because we did not draw table of value for this calculation, let's just pick an assumed average titer. And assume average titer to be 20.20 cm cube. This is our assumed average titer for this titration. All right. So this assumed titer is meant for KMnO4 because it is the one that we put inside our burette. Okay, let's continue. If you have to calculate number of moles, remember in the previous class I have told you that mole is equal to molarity multiplied by volume divided by 1000. So what am I going to do? Mole is now equal to the molarity of A is measured in mole per dm cube, and we have calculated that, which is 0.0100 multiplied by the average titer. Our assumed average titer is 20.20 divided by what? 1000. Talk to me, class. Our mole is equal to our mole is now equal to 0.000202, which is the same thing. The unit of our mole is still mole. The next question asks us to calculate the mole of Fe, which is the same formula. The same formula we use here is what we are going to use here as well. We just need to change. We change what? We are going to change the value. Roman figure 3 now. We want to calculate mole of iron. And then the concentration of iron is being given to be what? 0.0362 multiplied by our average volume, which is the volume of our pipette, is 25 divided by 1000. So here right now we are calculating for the mole of what? Fe. We've calculated the mole for what? MnO4 minus here. MnO4 minus. Let's press our calculator to determine our final answer here. Our mole here is now what? Our mole is equal to 0.000905. So that's our mole for iron. We've calculated the mole for MnO4, we've calculated mole for iron. Right now, the last question asks us to calculate the mole ratio. Our mole ratio is now 0.00. This is the mole ratio of the KMnO4, and then this is the mole ratio of the iron 2. The next thing is that we need to divide by the smallest in order to get a perfect whole number. And the smallest there is 0. The one of potassium manganese is smaller than that of iron 2. So because of that, we divide both sides by that of potassium permanganate. And this one will give us 1. But take note, in this case, because of the volume, the average volume of acid that we use, it can affect our final answer here. This kind of value, if it should be in organic chemistry, if you are calculating mole ratio, we're supposed to multiply both sides by what? By 2. Anytime you arrive at a point that is 0.5. If you arrive at a value that is 0.5, you just multiply both sides by 2 to round it up, instead of summing this one up to be 5. But right now, I will not do that because of assumed value that we use. So we can just say that it is 1:5. Our final answer is now 1:5. Reason being that we use an assumed value. This might not be the correct volume of A use. I hope you understand that. Thank you for watching. If you have not subscribed, please kindly do like this video and share to people that need this video. Thank you so much.